Today for math, we are going to review mixed numbers. Mixed numbers are pretty much the word, the name of the type of numbers. They're mixed. So it's not just fractions like we've been working with. It's also whole numbers. So, for example, 1 4/5 plus 2 1/10, because we're going to either add them or subtract them today. And if I look at 1 4/5, okay, and draw it out, it's saying I have one whole pie, if we use pi for example, and then I have 4 out of the 5 pieces of another pie. So I have one whole pie and then 4 out of the 5. So I actually almost have 2 whole pieces here. So let me estimate. Okay, so I'm going to round it to 2 because I almost have 2 full pies filled in. So I would round that up to 2. So that's what 1 4/5 look like. And then 2 1/10 means I have 2 whole pies filled in. And then 1 out of 10 pieces, which honestly isn't very much, right? So if I actually were to estimate this, I would round up to 3 because there's a lot missing there. I wouldn't even round it to 2 1/2 because it's still really small compared to half of the circle. So I would round it down to just 2. So if you had to estimate, all right, and add, our final answer should be close to 4, okay? But when we're gonna do like real addition with mixed numbers, we're actually gonna do, normal arithmetic, normal math. So let's go over that. So I'm going to do 1 4/5. Now what I want to see from you guys and girls, I want to see that you are doing your math vertically, not keeping it horizontal like that. Unless you leave enough room between them, because we have to change fractions, because we have to find common denominators. So here it is, dear ones. So I'm going to put a dotted line to separate the whole number and the fraction. It's just a reminder that I'm not going to add fractions to whole numbers, and I'm not going to add whole numbers to fractions. You add the fractions and then you add the whole numbers. So I'm going to start with the fractions. Always start on the right. So to add fractions, we need to find common denominators. Okay, so we've got 10 and 5. I know that I can change 5 into 10, and I don't have to go any higher. So I only have to change one fraction in this problem, okay? So to change 5 to 10, I multiply by 2, and multiply this by 2. So this gets me 8/10, and then I'm just going to rewrite 1/10 just so I have it right next to each other. So 8 plus 1, now I can add them. And don't forget, okay, you never add the denominators. It always stays a 10 once you find your common. So 8 plus 1 is 9. You only add numerators. And then finally, you just add your whole numbers together. That's 3. So if I put it all together nicely so it looks like it's together, 3 9/10 is the final answer. So you set it up, okay, so that your fractions are right underneath each other and your whole numbers are there. And then you either add or subtract. So now let me do a subtraction problem for you, just so you have that. So the next one is 4 5/6 minus 2 3/4. Now notice the good thing is they have the whole number, the bigger numbers first, which you'll want to put that on top when we rewrite it here, okay? And just by looking at this, I can see 6 and 4. I know I'm going to have to change both fractions to find a common denominator in this problem, because I can't turn 4 into 6, and we can't go down and turn 6 into 4. You never go down if there's a bigger number. Okay, but anyway, so I'm going to set this up. 4 5/6 minus 2 3/4. Put my dotted line in. You don't have to put the dotted line. It's just a reminder to say, oh, keep that on that side and this on this side. Okay, so for 6 and 4, I don't want to reduce too much in the end because we always have to reduce our final answers now. So I'm going to look for the lowest common multiple. So I'm going to do 6 and 4 and write out the multiples. Okay, so we got 6, 12, 18, 24, and then we've got 4, 8, 12, 16, 24. Well, I know 24 is a common multiple, but I don't want to be that high. I want to go lower and find, 12. Okay, so now we just have to change the fractions to have a denominator of 12. So 6 times 2 equals 12, and that means I have to multiply the top by 2 also. So this becomes 10, and then to get from 4 to 12, I need to multiply by 3. Multiply the top by 3, now it becomes 9 over 12, and now you have to look at your numbers. Okay, I can subtract, because we're subtracting here, 10 minus 9, and I'm left with 1. And don't forget, denominator stays the same. And then I can subtract my whole numbers. 4 minus 2 is 2. So my final answer is 2 and 1/12. All right, so just an FYI, if I turn these into 24, if I turn the denominators into 24, I'm going to write that in a different, watch, I'll show you the remake here. If I did it 24, which you could, but then in the end you have to reduce. 6 times 4 is 24, so 5 times 4 is 20. See how much bigger it is than the smaller one you could have made? Just gonna, okay. And then 4 to 24 is times 6. So 3 times 6 is 18. So if I were to subtract 20 minus 18, that would be 2 24ths. And 4 minus 2 is still, oops, excuse me. 4 minus 2 is still 2. So my whole number would be fine. So I can write 2 all alone. But then I have to think, oh, I know 2 and 24. I know I can divide 2 out of both of those. So I would have to reduce, people, which is dividing the same number out of top and bottom, which would still get me to the right answer, but you can't forget to reduce in the end. Or you want to simplify. So, no equal sign there, just 2 1/2. Or, excuse me, 2 1/12. So those are 2 examples, dear ones, of what you'll be needing to do today. So in your math book, I have your assignment on Google Classroom, but in your math book on page 385, I want you to do numbers 5. You're doing all the numbers 5 through 23. You're not doing all of them, you're doing the odds. So you're going to do 5, 7, 9, 11, continuing on to 23. And please do them in your math notebook so I can see all your work. Because as you can see, this is not just a simple addition problem. There are nice steps to it. So I expect to see some work changing in the fractions. So please show me your best work, okay? Show me how your strategy here. All right, happy math working.